Hello everyone, my name is Ribeiro and I'm here today to present the paper named Real-Time Detection of Vehicle-Based Logistics Operations. In this presentation, I will show the application of a methodology for exploiting geolocation data in order to identify business operations in real time. Let me start my presentation with an overview of the topics I will cover. First, I will introduce the business context and motivation. In this topic, I will describe the business process this work focuses on. Second, I will present the methodology applied in this work. This methodology is actually an adaptation of another one that can be found in the literature. Next, I will show a case study that was used as a preliminary evaluation, and I will end the presentation with a small discussion, conclusions, and future work. The main concept of this work is that geolocation data can be transformed into meaningful events. Assuming that there is a system capable of collecting geolocation data, we can track the position of some object over time. If we identify the places where the object stopped, then we may be able to detect automatically some business operations. The challenge is to know what is an actual operation because some are just random events. So, in this work we apply this concept in a logistics company which operates in the European market and relies on over 2,000 vehicles to transport goods from a location to another. Even though the company uses a fleet tracking system, the workflow monitoring still relies on information generated by human resources, which has proven to be ineffective due to delayed, imprecise, or missing inputs. The target is to have an automatic mean for detecting the execution of load and unload operations. This slide presents an overview of the business process. Each process instance is a work plan for a vehicle, and each work plan contains a sequence of load or unload operations. Remark that every operation in the work plans mentions where the operation is supposed to happen. The integration of this information with the geolocation data will enable the automatic monitoring of the workflow. The exploitation of geolocation data for the detection of logistic operations is an opportunity for improving the monitoring and management of logistics operations. The most interesting opportunity for the company is related to the customer service. This solution may provide means to negotiate contracts more adjusted to reality, and also it may enable on-the-fly notification to customers about their packages. In this and the next slides, I will present the methodology used in this work. As I already mentioned, the methodology relies on three main stages. The first one is related to the geolocation data, from its collection to its preparation. The second one is related to the stationary events, which consists of computing the locations where the vehicle stopped. The third one is about associating stationary events to logistics operations. I will present more details about these stages in the next slides. So, geolocation data is considered as a stream of geolocation entries provided by some fleet tracking system. The main issue related to geolocation data is the uncertainty or missing data. A good example is the GPS error, which makes the geolocation uncertain. An important aspect to take into account is the cadence we receive the data. For instance, we may receive the data every second or every hour. If we receive the data every second, we will be able to track all the motion of the vehicle. On the other hand, if we receive the data every hour, we will have only one small picture of the motion and we may miss a lot of events. The computation of stationary events is performed using an algorithm presented in this paper. This algorithm takes geolocation entries as an input and returns a stationary event if detected. Data noise is the main issue at this stage, which is addressed using some heuristics. An important aspect to take into account is the minimum duration for the events. For example, the loading of goods is not supposed to take less than 1 minute or so. Another algorithm is present to relate stationary events to logistics operations. Basically, this algorithm searches the work plans that are active for finding a match between some stationary events and a logistics operation. It is important to mention that the matching must make sense in terms of workflow. For instance, if there is some work plan that is not active yet, so it makes no sense to say that some event explains the execution of one of its operations. Aspects to consider at this stage are the maximum distance to the location of the operation and the time of search range. The maximum distance defines how far a vehicle can be from some place to be considered performing the logistics operation. In this work, we have considered 1000 meters as the maximum distance. The time of set range defines a time window for starting a work plan. It's usually defined as -5 hours to +12 hours regarding the expected start time for the work plan. The main issue at this stage is that operations may be located close by. This means that it may not be possible to know the end of an operation and the start of another. In these cases, we have to aggregate them. A third algorithm is present for the real-time computation. This algorithm makes use of the other two algorithms to transform the geolocation entries into logistics operations. The main challenge in this algorithm is to be sure of the effective end of operations. It's not uncommon that the vehicle gets away to return afterwards, so the end of the operation may be wrongly identified. An important aspect to consider is that multiple operations may be detected at the same time, as explained before. This means that the quantification of the operation must be adjusted. This means that if we have two operations that were detected at the same time, then the duration of them should be split in two. As a preliminary evaluation, we have tested the methodology with 1 month of real-life data for 3 vehicles. This table provides an overview of the used data. For instance, for vehicle V1, we analyzed almost 30,000 geolocation entries with an average cadence of 92 seconds. From this, we identified almost 600 stationary events. In this month, this vehicle had 18 work plans, including 36 operations. With our methodology, we were able to detect 35 out of 36 operations. Also, we were able to fully describe the execution of 17 out of 18 work plans. Another interesting figure is that only 35.7% of the stationary events were identified under the context of a work plan. This provides some insight into the vehicle usage. Regarding the performance of the vehicles, we are able to quantify indicators such as the throughput time, delays, and operation times. For instance, B1 takes more than 12 hours on average to finish the work plans, or it usually starts the work plans 3 hours before than expected. Also, it takes almost 5 hours on average to perform an operation. A different perspective of analysis is the common work plans or operations. The example in this slide shows a common work plan with just two operations. A loading operation at the location A and an unloading operation at the location B. The maps identify where the events took place, while the tables quantify some indicators. This information is quite important to adjust contracts with customers. Just before concluding my presentation, I would like to emphasize what we have learned with this work. Our goal is the application of geolocation data for monitoring operations of a logistics company. For that, we had to adapt and implement a methodology based on stationary events to run in real time. A preliminary evaluation showed that we can detect almost every operation. The few operations that we were unable to detect are due to location conflicts. With this work, we learned that it is possible to use geolocation data for workflow monitoring in real time. The generated information may provide insight into the execution of logistics processes, either for performance analysis or conformance checking. We acknowledge that focusing only on the loading and unloading operation is a limitation of this work. Another limitation is the fact that we need a database of locations for the logistics operation. As a future work, we identify three topics. First, the inclusion of all kinds of operation in the detection, and for that we need to be able to classify automatically the stationary events, which may be based on points of interest. Last but not least, we would like to apply process mining techniques to get further knowledge about the logistics processes. With this, I finish my presentation, and I would like to thank you for your attention, and I'm looking forward to hear your feedback or some questions you might have.